we're going to be moving 2 hours by plane west to Chicago.
West. All right. Let's hear about all the best in the Midwest. I have Ben here in Chicago. How are you doing, Ben?
I'm doing all right, Dan. How are you guys doing?
All right, awesome. So why don't you tell us about this first project we're going to see here today?
Yeah, so to kick us off, our first of 7 projects here in sunny, warm, balmy Chicago, Illinois, is Team Whisk. I've been thinking, you know, as modern humans, we are fortunate to be able to offload more and more of our day-to-day tasks to robots. And this team has created what I like to think of as a benevolent overlord of menu planning. So here to tell us about it is Team Whisk.
Hi, I'm Patrick, and these are my teammates Dilan, Lukas, and Sophie. As busy people, we struggle to make time to cook for ourselves and don't want to spend time searching endlessly online, which is why we built Whisk, a recipe recommendation app that serves up recipes based on your likes and dislikes. Upon signing up for Whisk, I'll be asked about my preferences and requirements. I would never want to see walnuts as I'm allergic, so I will let Whisk know about that. One preference I have is that I love quinoa, so I would like to see quinoa more often in my recipes. I also love Indian cuisine, so I would like to see that more often. Now Whisk will show me more recipes with Indian cuisine. Now I'm going to hand it off to Dilan to talk about what you see here.
Our recipe data came from an adapter module we built. This enabled us to convert data coming from potentially various sources into a form we can use in our database. You can see that my recommendations are different than Patrick's because Whisk knows that I have different preferences. In my homepage, I can browse the recommended recipes for me, as well as recipes that are popular, trending, and recipes I have never seen before. I can click like and dislike to teach Whisk about my preferences and save a recipe for future use. With this information, Whisk will get smarter and give me more accurate recommendations over time. In order to support our recommendation engine, we used a hybrid backend consisting of a relational database called Postgres and a graph database called Neo4j. Our Postgres database kept the most of our models, but we used Neo4j to keep user interactions and give recommendations. While giving recommendations, Whisk finds users who have similar preferences to each other and then recommend recipes based on what it thinks it would be a good match by this similarity. Now I'll hand it off to Lukas to talk more about our recipe search feature.
If I have something specific that I'm looking for, I can search recipes by title, category, ingredient, or any combination of the above. I know, for instance, that I have a lot of quinoa that I'd like to cook tonight. Typing this ingredient in, I immediately see a list of possible recipes for this evening. I know that I'll be pressed for time after work, so I filter for recipes that take less than 25 minutes to cook. To make search fast for our users, we used debouncing on the front end to delay requests until a user has finished typing. On our back end, we indexed each recipe using a text search vector. When a user inputs a search, it's converted to a set of normalized keywords which are used to match directly with recipes in our database. Now I'll hand things off to Sophie to talk about our chatbot.
One of the hardest things about learning a new skill is practicing it consistently enough that it becomes a habit. Our app aims to change that by making cooking part of your routine. Whisk chatbot sends up to 3 scheduled texts a day to get you in the habit of cooking. The chatbot is interactive, so your input affects how it will talk to you. Here you can see an example conversation. In the morning, the chatbot asks what I want to cook that day. I can respond with show me, and it will give me a recommendation based off of my preferences. If I don't like the first option, I can choose something else. Likes and dislikes add data to the recommendation engine, just like in the web app. Whisk chatbot is constructed using Twilio, which uses webhooks to notify our app of incoming text messages. Webhooks are custom HTTP requests capable of sending real-time data to and from our app through its configured URL. When a text message comes in, it triggers a webhook, which tells our Express server to get the requested data from the database. The database sends it back in the form of XML, which Twilio then uses to send an SMS message back to the device. The challenges we faced involve integrating a number of new technologies, including Neo4j, Heroku, React, Redux, and Cypher. Thanks for listening to our presentation on Whisk, and happy cooking.
Oh, impressive stuff. And not only was that technically very robust, but I could see myself using it every day as an aspiring amateur chef. I'm aspiring to be an amateur chef, I mean. So just having these simple, time-sensitive recipes at my fingertips, that's a huge win.
Yeah, interesting to me. Like Twilio is another example of a place where it's hard to manage state properly because you have to, you can't, there's no session in the underlying phone call, so you have to kind of reestablish that. It's just a different way of thinking about, how you identify users. But I think chatbots are a great thing that people are adding to engage with people in just a very different way. And I know one thing is that when I want to ping students afterwards, like email, Slack, all that stuff doesn't work as well. People get on their texts.
Yeah.
So.
Yeah, old habits die hard. And working between the HTTP and SMS protocols is definitely a meaty technical challenge.